So now what I'm going to do is I'll give you another game. Okay, so what do you think? How many strategies or how many plans player one has? 4 plans. Very good. Because he can veto any of them, right? He can veto either A, B, C, or D. So player one has 4 plans. How many plans player two has? Player two has 81 plans. Very good. Because at each of these nodes, where player one is going to move, player two is going to choose. Okay, now how many plans player three has? Very good. Okay, 2 to the power 12. Is that clear to everyone? So in how many ways can this game be played? Very good. 4 ways in which player 1 can choose his plan, 3 to the power 4 ways in which player 2 can choose his plan, 2 to the power 12 ways in which player 3 can choose his plan. So the total possible ways in which this game can be played is 4 into 3 to the power 4 into 2 to the power 12. So that's that's not a small number. Okay, so let's solve for subgame perfect equilibrium in this particular situation. So first of all, I'm going to solve all subgames of length 1. Okay, so when do we what do you mean by subgames of length 1? So you can just imagine a tree like this. Okay, player 1 is going to choose one of the 4 players to veto. Okay, and then player 2 is going to choose from the remaining 3 players one of the players to veto, and then player 3 is going to choose from the remaining 2 players one of the players to veto. Okay, so this is the game that we are going to analyze first. Okay, so if you really think about it, it doesn't matter who is vetoed first, who is vetoed second. What matters is when player 3 is moving. Okay, when player 3 is moving, what matters is what all players are left. Do you agree? If he's going to write a computer program, he can just tell the computer that, okay, when I'll get a move, there are actually 12 possibilities, okay, where I get a move, but out of those 12, I don't have to bother about the remaining 6 because they are actually kind of copies of the other 6. Why am I saying this is because if you really think about it, these are the 6 possible situations that player 3 can find himself in. He might be choosing to veto between A and B, okay, or A and C, or A and D, or B and C, or B and D, and finally C and D. These are the 6 possibilities, right? I agree that there are 12 possibilities, but I can shrink that to 6. The reason why I can shrink that to 6 is because this possibility can arise because of 2 reasons. One is player 1 vetoes C and then player 2 veto D. The other is player 1 veto D and then player 2 veto C. Okay, so this particular thing can arise because of 2 reasons. So I don't really care how it came here. I can just program my computer, that, okay, if these 2 players are left, then this is what you should do. So if I do it this way, I have a complete plan. Is that clear to everyone? Okay, so what do you think player 3 will do in this case? So if you look at the player 3's payoffs, player 3 gets a higher payoff from choosing B than A. So he's going to veto A, right? So who will be left in this case? B will be left. So B will be the winner. What do you think player 3 will do in this situation? AC, veto C. So who will be left? A will be left. What do you think player 3 is going to do in this situation? A and D. Veto A. So D will be left. What do you think is he going to do in this situation? B and C. Veto C. B will be left. What do you think is he going to do in this situation? Veto B. D will be left. And what do you think is he going to do in this situation? C and D. Veto C and D will be left. Do you agree? Okay, now we'll keep this in mind that this is what player 3 is going to do and this is what will happen. Okay, and then figure out what player 2 should do. Okay, so player 2 is going to move when player 1 has already moved and vetoed one of them. So there are four possible situations where player 2 can find himself in. Okay, one is that A, B, C are left. The other is A, B, D are left. Okay, then you have A, C, D are left, and then finally B, C, D are left. Okay, these are the four possible situations. Yes or no? Okay, now player 2 is going to step into the shoes of player 3 and can exactly figure out what player 3 will do in these situations, because player 2 knows player 3's payoffs, so he can always solve the game and figure out what player 3 will play. So he's going to take that into account while he's going to make a choice between A, B, and C. And that's basically the idea behind backward induction. Okay, so he's going to say that, okay, if I veto A, then B and C will be left. Okay, and if B and C will be left, then B will be chosen. So what I'm going to do is I'm going to write that on the top. Okay, that if I veto A, then B will be chosen, because if I veto A, player 2 is going to think, if I veto A, then B and C will be left. Out of B and C, player 3 will veto C, then B will be chosen. So if I veto A, I'm basically saying that, okay, choose B. Okay, if I veto B, okay, so if I veto B, then A and C will be left. If A and C will be left, then player 3 will veto C, so A will be chosen. So vetoing B is like choosing A. Okay, similarly, if I veto C, then A and B are left, and if A and B are left, then B will be chosen. Okay, so now I have to compare between A and B. Okay, so I'm going to look at this, my payoffs. Okay, so playing so if I so between B and A, B gives me higher payoff than A. So I can either veto C or A, doesn't matter, I can choose one of them. So let's say I veto C. Okay, and I know that if I veto C, then B will be chosen. So I can just write for for the sake of when I'm going to do the same thing for player 1, then I don't have to go ahead and check here. I know that the consequence of vetoing C is B will be winning eventually, because out of A and B, the B will be the winner. Okay, so let's just do the same thing here. So if I veto A, then B and D are left. If B and D are left, then if B and D are left, then D will be chosen. If I veto B, then A and D are left. If A and D are left, then D will be chosen. Okay, if I veto D, then A and B are left. If A and B are left, then B will be chosen. Okay, and then between B and D, player 2 prefers B, right? Player 2 prefers B. So if player 2 prefers B, then he should choose D. Okay, so veto D and get the preferred outcome. Is this clear? Okay, let's do the same thing here. If I veto A, then C and D will be left. If C and D will be left, player 3 will make sure that D wins. Okay, if I veto C, then A and D are left. If A and D are left, then player 3 will give me D. Okay, if I veto D, then A and C are left. If A and C are left, then A will win. And between A and D, I like A more, so I'm going to veto D so that A is chosen. So let's do the same thing over here quickly. B, CD are left, CD are left, D will be chosen. C, BD are left, BD are left, D will be chosen. D, B and C are left, B and C are left, B will be chosen. And then between B and D, player 2 prefers B, so he's going to veto D. And the outcome is B. Okay, now player 1. Player 1 gets a move, initially, okay, where he has a choice between A, B, C, and D. So he's just going to evaluate each of his actions and he's going to figure out what is his best move. And he's able to guess again, thinking backwards, he's able to figure out what player 3 is going to do here, what player 2 is going to do. He can step into the shoes of player 2 and he can imagine the game the way the player 2 is imagining the game. Okay, and he can see the payoffs of player 2, so he can also calculate player 2's move, and so he'll be able to figure out that if I veto A, then BCD will be left. If BCD will be left, then B will be chosen. Okay, and if I veto B, then ACD will be left. If ACD will be left, then A will be chosen. Okay, and if I veto C, then ABD will be left. If ABD will left, then B will be chosen. If I veto D, then ABC left, ABC left, and B will be chosen. Between A and B, player 1 prefers A, so he's going to veto B. Okay, so veto B, and that's it. So the subgame perfect equilibrium outcome is, so this is the outcome. Okay, this is not the strategy. So the outcome is veto, player 1 will veto B. Okay, veto B, 1 veto B, 2 veto what? So 1 veto B, then 2 veto D. Okay, and 3 veto what? When 2 veto D, then D, then A veto D, then AC will be left. If AC will be left, he's going to veto C, 3 veto C. Okay, so this is subgame perfect equilibrium outcome. And what is the equilibrium strategy profile, or what is the equilibrium? So how you can write the equilibrium? It's right here in front of you. Player 1 veto B. That's player 1's strategy. Player 2 veto C in this situation, veto D in this situation, veto D in this situation, veto D in this situation. Okay, that is player 2 strategy. Player 3 strategy is veto A in this situation, veto C in this situation, veto A in this situation, veto C in this situation, veto B in this situation, veto C in this situation. That's player 3 strategy. So this is the Nash equilibrium, subgame perfect equilibrium. And this is the subgame perfect equilibrium outcome. Subgame perfect equilibrium outcome. Okay, and this is in the box subgame perfect equilibrium. Okay, and what are the subgame perfect equilibrium payoffs? The subgame perfect equilibrium payoffs are U1A, U2A, and U3A, because A is the outcome, that is A is the final candidate who is not vetoed. Okay, so this is the equilibrium payoff.